Hi, I'm Sergey, and I run the engineering organization over at Clustrix. In a moment, I'm going to show you a live demo of how Clustrix handles node failure. But before I start, I'd like to give you a quick introduction to our system. Clustrix is an incrementally scalable distributed database system. It's a fully featured relational database, and we are on-the-wire compatible with MySQL. Now, we don't actually have any MySQL code in the system. It's a database that we built from the ground up. But we reverse engineered all of their protocols, and we emulate their SQL semantics so that folks that have a MySQL deployment already can simply put Clustrix as a drop-in replacement to their database, and all of a sudden they have a scalable, fault-tolerant, easy-to-manage system. You can get more information on Clustrix at www.clustrix.com. So I set up a basic 3-node cluster for us to use. It's the minimal configuration required by Clustrix. As you can see, I'm using the MySQL client utility because we do emulate the MySQL protocol, but you'll quickly notice that it's not quite MySQL. We have a built-in system database that's analogous to the MySQL database. It has information about the system and the cluster in general. We can take a look and see who the member nodes of the current group are. So here it is. We have a basic 3-node cluster with our shipping hardware. I also populated the cluster with the benchmark data set that we used in the previous post, although it's a scaled down version of it, just so that we can have some real data in the cluster while we're conducting these failure tests. So you can see that files table, and we can take a look at what its schema looks like. Very much like MySQL, but you'll notice that we also give information about the distribution hints that the system is currently using for this table. Okay, so why don't we go ahead and just turn off one of the nodes. We have power controls for our colo facility, so I can just hop onto this window and I can say power control, let's see, 016 was I think one of the nodes, and just turn it off. And there we go. So in general, by default, cluster waits some predetermined amount of time. I think by default something like 10 minutes before it actually starts migrating data and reprotecting it from the failed node. The premise there being that we can have a node restart happen because of a power event or some other problem, and that it's going to come back quickly. So there's no reason to cause a full reprotect operation to start. Okay, so let's go back and see what's happening with the cluster. So we can go back to the system database, take a look at the membership table, which gives us information about which nodes are currently online. And you can see that node 1 is actually in static membership. That means that it's not online, it's not participating in the quorum group. So then we can also change the default interval. So show global variables like Q, set global rebalancer protect Q interval, and this is in seconds, and so let's just say, okay, 15. Great. So now we can go ahead and see what's going on with the rebalancer. Start from rebalancer summary. Oops. So this table gives us information about what's currently happening with the rebalancer, and you can see that we've spun up quite a few copy tasks, which are really reprotect tasks within the system. So what's interesting is that I can go back to the benchmark database, and I can take a look at what's in files, right? So let's say limit 10. So there we go. We have some information. So why don't we try updating just a couple random records? So we can say update file set I don't know, path equals foo where ID in, I don't know, this set of files, right? So there we go. So what's interesting about this is that the copy operation does not at all prevent or interfere with the writes going into this table. We can keep on doing this. You can see the response from the cluster is pretty quick. We can go back into the system database and take a look at the rebalancer summary again. We're actually getting pretty close to finished. We can take a look at what the rebalancer did in the recent past. So we can take a look at the rebalancer activity log file, and we should order by 8. I know it's the 8th column, descending, limit 10. How about limit 3/G? So we can see which portions of the database the rebalancer last operated on, how long some of these copies took, and what the outcome was. So error null means that there were no problems with the copy. If we wait long enough, the database will simply finish the reprotect operation, and the cluster would have gone successfully from 3-node cluster state into a fully protected 2-node cluster state. So what I would like to point out about this test is that I did absolutely nothing to the database after it encountered the failure. The database automatically recognized that a node left the group. It automatically started the reprotect operation. It started copying the data over to the remaining 2 nodes. If we had waited long enough, we would have seen that the cluster would have become fully protected in 2-node configuration. And then we can just go and repeat the exact same scenario in reverse. We would put the node back in. It would recognize that it had stale data, just remove that data. And then to the rebalancer, it will simply look like there's a new node that joined the cluster. It will think that there is some sort of a load imbalance and start moving the data back. And again, all of this is transparent. Operator didn't need to do anything, and the application wouldn't have noticed anything either. So that's it for my test, and thanks for taking the time to listen to this and watch the video.